looking at this page here, page 3, hopefully you went through page 2, the discussion on page 2. I've already made this entire argument, but here's a little visualization of what's going on. Remember, we called the distance between the two of them h. So this was the distance between the two of them, h. If you notice what's happening in every single one of these pictures, we're getting h smaller and smaller and smaller. The distance between the 2 points is smaller and smaller and smaller. So we've gotten to a point where h has approached 0. Once h has approached 0, we have now found the slope of the tangent line. So the slope m of a graph at a point f, x, comma, f of x, is equal to the slope of the tangent line of the graph f at x f of x, and is given by m equals the limit as delta x approaches 0 of m secant, which equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, provided the limit exists. What the heck just happened? What in the heck just happened? Here's all we said. If you want to find the slope of a graph at a point, that's the same thing as the slope of the tangent line at that point, which is the exact same thing as the limit as h approaches 0 of f of x plus h minus f of x all over h at the point. So they use delta x. So they say delta x goes to 0. I say h's. And I like it much, much better with those h's. But here's what we've determined. The slope of the graph is the slope of the tangent line, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. That's a summarization of that page.